Today we're going to put together a lot of the concepts we've learned throughout the year in order to sketch a good curve of a graph. We won't always have our graphing calculator. They won't always ask for the graph. They might ask for a step along the way. So being able to do all of these steps in order to sketch a good graph is very important. First step being finding the domain. Remember that anything under a radical has to be greater than or equal to 0, and our denominator cannot equal 0. Also, y-intercept, to find where it crosses the y, find f of 0. Find out where it crosses the x, set f of x equal to 0. Symmetry. Even functions are symmetric with respect to the y-axis. Odd functions are symmetric with respect to the origin. And then periodic functions are trig functions, functions that repeat what they do over and over and over. Asymptotes. Find our limits at infinity and negative infinity for our horizontal asymptotes. Vertical asymptotes are where the denominator equals 0. We might be helpful, not always absolutely necessary, is to find when we approach our limit whether it goes up or down, so we know what that looks like. And then we're going to learn about slanted or oblique asymptotes in the next video. Intervals of increasing and decreasing. Find the derivative. Make your number line. Local max and mins. Look at your number line. See where it goes from positive to negative for local maxes and negative to positive for local mins. Concavity. Find the second derivative and make a number line. Also, think about points of inflection. So, finally, we sketch the curve. So, let's try one together. Letter A wants us to find the domain, and that would be the denominator is not equal to 0, so x can't be plus or minus 1. So our domain, negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Keep that in mind for our sketch. B, intercepts. F of 0 is equal to 0, so we know that it crosses the y at 0. Where does 2x squared equal 0? Well, that's when x is 0 also, which makes sense because it already touches the x-axis at 0. Part C wanted us to find symmetry. So what happens when we plug in a negative x? We get 2 times negative x squared over negative x squared minus 1, which works out to be the exact same function, meaning this function is even, which in your mind you need to be thinking symmetric to the y-axis so that you kind of know what it looks like. Part D, asymptotes. Well, asymptotes happen where the bottom equals 0, so we have 1 at 1 and 1 at negative 1. So I can go ahead and sketch that. Horizontal asymptotes are the limit as x approaches positive and negative infinity. And to do that best, we should divide everything with the highest power of x from the denominator. So we get 2 over 1 minus, and whether we plug in positive or negative infinity in for x squared, we get 0. So our horizontal asymptote is 2. Y equals 2 for the equation. Now, part E wants us to find increasing and decreasing. So we need f prime of x. We get low, d high, minus high, d low. Draw the line. Square the low, which gives us 4x cubed minus 4x minus 4x cubed over x squared minus 1 squared. Now on our number line, we know weird things happen at -1 and 1, so we need to check between them. And if you check between them, oh, and at 0, sorry. I'm not going to go through all the work, but I'm just going to tell you we get positive, positive, negative, negative. So we know that it's increasing from negative infinity to 1 and to -1, sorry, and -1 to 0, and decreasing from 0 to 1 and 1 to infinity. So keep those in mind as we sketch. So, local maxes and mins, looks like we have a local max at x equals 0. If we plug 0 into our original equation, f of 0 equals 0, so we have a local max at 0, 0. And that point's already on our graph, so we don't need to draw it. Finally, what comes after f? Oh, it's a g. Concavity, so we need second derivative, which is low d high minus high d low. Draw the line, square the low. Not cubed, that would be x squared minus 1 to the 4th. So, I'm going to factor the top a little bit. I'm going to pull out that x squared minus 1. I can pull out one of them, which leaves me with -4 times x squared minus 1 in my first term. And it leaves me with -4x times 2 times 2x in the top. And we've got x squared minus 1 to the 4th remaining in the denominator. Now these can cancel. Change it to the 3rd, and let's simplify what's at the top. We get -4x squared plus 4 plus 16x squared, which makes it 12x squared plus 4 over x squared minus 1 cubed. Now when we make our number line, we already know what points we need on it because we have already dealt with them some, or where this graph is undefined, which would be at 1 and -1 from the denominator. When we plug those in to our second derivative, we get a positive, a negative, and a positive, which means concave up, concave down, and then concave up. So, now we need to put this all together into our graph. To the left of -1, excuse me, it is increasing and concave up. We know that it approaches 2 as it goes far to the left. So, increasing concave up means it about has to look something like that. In the middle, we have a max of 0, 0. We know it's increasing from -1 to 0 and from decreasing from 0 to 1, but concave down the whole way. So, looks something like this. Again, feel free to rewind or pause if you need to hear what I say again. Now to the right of 1, it's decreasing and concave up and approaching 2, out to the right, so we know that it looks like this. That's all I'm going to show you today. I want you to take a few minutes, sketch the graph for the example on the back, come to class tomorrow with questions, and we will talk about it then.